Okay, now let's solve question number 5. In question number 5, it has been given that a particle is undergoing a uniform circular motion having speed of, let's say, v. Now you have to find what is the change in velocity that the particle has when it moves from point P to point Q, and point P and Q are symmetrically placed with respect to the center. Okay, so this is a very basic kind of problem in which you just have to break the vector into its component. It's basically for practice. So you actually spend a minute or two in this and you find your answer. And just before that, I'll tell you one thing. This circular motion we are going to study in the coming chapter in quite great of detail. But for now, I must tell you, just for the sake of solving this problem, that when a particle is moving in a circular motion, then the velocity is tangential. Tangent is perpendicular to the radius. Velocity is tangential, meaning the velocity is perpendicular to the radius always. When the particle is at this point, then the velocity would be in this direction and it would be perpendicular to the radius. When it comes to this point, it is again perpendicular to the radius at any given point. At that particular moment, the velocity is perpendicular to radius. It is always perpendicular to radius in a circular motion. And in uniform circular motion, speed doesn't change. So actually, it's just the direction of velocity which is changing. So fine. So why it is so, we'll see. But for now, for the sake of solving this problem, assume it. If you don't get a feel of it, just assume it, that the velocity is perpendicular to the radius at any given point. Now, what you have to do is you have to just break the velocity into components in the form of I cap and j cap at P, in the form of I cap and j cap at Q, and find the change in velocity. Okay, so spend some time in this, get your answer. Okay, so I assume that you have got your answer. And let's see how one would approach solving this problem. What you have to do is you have to break this velocity into its component, x component and y component. So this angle, and using very basic geometry, I'm sure you must have found, because this angle is 25 degree, because I told you P and Q are placed symmetrically with respect to origin. So this angle is 25 degree, so this angle would be 55 degree. If you use a very basic geometry, you will get it, and I'm sure you must have got it. So this angle is 55 degree, and you had enough practice of finding the component of a vector along a line when the angle between the vector and the line is given. In this case, the angle between the vector and the line is 55 degrees. So the component of this vector along this line will be v times cos 55 degree. So this component, the given vector is like this. X component of the given vector is v cos 55 degree. And similarly, the y component of the given vector will be v sine 55 degree. Now to break the vector into component and write in the Cartesian form, we can write velocity vector at P is actually v cos 55 degree I cap, and the one which is along y-axis is along negative y-axis direction, so it will come as minus j cap. So this v sine 55 degrees actually in minus j direction. V sine 55 degree j cap. This minus because it is along negative y direction. Similarly, if you do the same analysis, you'll get the velocity vector at Q as v cos minus v cos 55 degree I cap minus v sine 55 degree j cap. Now change in velocity, change is always final minus initial. Change in velocity here, change in velocity vector is v at velocity at Q minus velocity at P. That is 2v cos 55° I cap. This is a change in velocity. Now sometime you may not find this option, this answer in any of the options given. What you may find as is 2v sine 25° I cap, which is also the same as the given answer, right? Because cos 90 minus theta is sine theta, sine 90 minus theta is cos theta. That property we know already. So fine. So what we are learning here is, in a situation like this, when the vector is not aligned either along x-axis or y-axis, we break them into components and align the component along x and y-axis. That makes the analysis very easy, as we will see when we progress in the course. Okay, let's solve one last question in this section, which will be very interesting. And if you solve this one really, then whatever we have learned up till now, whatever you have learned up till now, will pay off. This is a regular hexagon. Regular hexagon meaning all 6 sides are of same length. And let me name it as A, B, C, D, E, and F. O is the center. Now they're asking you AB vector plus AC vector plus CD vector plus AB vector plus AC vector plus AD vector plus AE vector plus AF vector is equal to x times AO vector. X is an integer, 1, 2, 3, 4, 5, 6, 7, 8. But you have to find what is x. Now AB vector, with a symbol you will understand that AB vector is the one that which starts at A and ends at B. So this is AB vector. Similarly, AC vector is the one which starts at A and ends at C. This is AC vector. Similarly, you know all the 5 vectors. So it is x times AO vector. AO vector is this. Starts at A, ends at O. So you have to find the value of x. Spend a minute or two with this. Actually, if you are able to solve this one, you will be very gratified, because this is the last problem we are doing in this section before you go again into the resolution of vector. So basically, in the addition of vector, if you have learned the theory well, if you have concentrated up till now, you should really relish solving this one. Okay, I assume you have got your answer. Now let's check. Let's start with the easy one, AD vector. Now since it's a regular hexagon, if we draw AD vector, that is going to cross through the center. And this is very clear from here that AD vector is twice that of AO vector, because it's on the same line and it's just the difference of the length. So this AD vector can be replaced by 2 times AO vector. Similarly, if you see AF vector and AB vector, and if you just think of parallelogram law of vector addition, if we join OF and OB, now AFOB is a parallelogram. Now think about it, why? Parallelogram is a 4-sided closed polygon in which opposite sides are parallel to each other. Now this angle is 60 degrees because the internal angle in a hexagon is 120 degrees, and this will bisect, OF will bisect angle F. You can think of it from the argument of symmetry. This angle and this angle would be the same. So this angle is 60 degrees and this angle is 120 degrees, internal angle of a hexagon. So if you think of AF as a transversal, this line, this is 60 degrees and this is 120 degrees. So internal angle on the same side, the sum of them is 180 degrees. So this line AB and line OF are parallel angles. When you have parallel lines, when you have parallel lines and you have a transversal like this, the sum of internal angle is always 180 degrees. This property you must have studied in class 9th or 8th. So applying that here, this proves that OF and AB, OF and BA are parallel lines. So, and if you apply the same concept for the other two sides of the quadrilateral, they will also come out as parallel, and hence this is a parallelogram. Proved. Now, if it's a parallelogram, then AB vector plus AF vector, the sum of them would be one of the diagonal of the parallelogram, which have the same tail. All three, the sum, the resultant, and the two vectors have this common tail. So this AO is actually the resultant vector for AB vector plus AF vector. So this AB vector and AF vector, they together can be written as AO vector. Fine. Now you have to worry about AC vector and AE vector. Now let's see AC vector. Now again you think of triangular law of vector addition. AC vector plus CD vector would be AD vector, isn't it? AC vector plus CD vector. Now there is no CD vector here. So let's do one thing. Now this AC vector plus CD vector, I'm adding CD vector in this expression, so I also have to subtract CD vector. But AC vector plus AC vector plus CD vector is AD vector. Now you have to be very handy with triangular law of vector addition, and you don't have to do mistake in the signs. You don't have to say that AC vector plus CD vector is DA vector. This practice we had before. For the time to come, and the time has actually started to come, AC vector plus CD vector is AD vector. So this can be written as 2 times AO vector. Similarly, AE vector plus ED vector. This AE vector plus ED vector. This will be equal to again AD vector 2 times AO vector. But what I have done actually is I have added CD vector and ED vector, so I have to subtract CD vector and ED vector from the expression. If you see CD vector, minus times of CD vector is DC vector. We know that this direction changes if you just append a minus sign with a vector. So minus CD vector is actually DC vector, and minus ED vector is again DC vector. So this is actually plus DC vector plus DE vector. Okay, now DC vector plus DE vector, as we did for AB vector plus AF vector, is equal to AO vector. Similarly, from the other side, DE vector plus DC vector will be equal to DO vector. Okay, now DO vector is negative of OD vector, and OD vector is same as AO vector, because the direction of AO vector is same as OD vector, and the length is also the same. AO vector has been shifted parallelly. If you shift parallelly, you will get OD vector. So this effectively is written as negative of AO vector. So this is minus of AO vector. Okay, if you do the summation, you will get as 6 times AO vector. Okay, it was a nice problem. Did you relish this? Oh yeah, you did. Good. So the answer X is equal to 6. Okay.